Hi guys, today we're going to be looking at parallel and perpendicular lines. The important thing here to get out of today is really understanding the relationship between gradient and how that affects the equation of a linear graph. So let's get into it. So the aim for today is to go over the 5 things here. To know the meaning of the term parallel and perpendicular, to know that parallel lines have the same gradient, to know that gradients of perpendicular lines multiply to equal -1, to be able to determine if lines are parallel or perpendicular using their gradients, and finally to be able to use their equation to find the equation of another line that is either parallel or perpendicular of another line. So before you start, I'm assuming at this stage you have looked at finding an equation. So what I want you to do is, if you are watching this video, is to find the equation of those lines below. And I want you to write down what you notice in terms of the gradients. So let's have a look at parallel lines. Parallel lines are two lines that never cross. So we have 1, 2, not very good parallel lines, but they are, let's, for the sake of the explanation, they are parallel. On a Cartesian plane, parallel lines have the same gradient. And if you're to look at it, it kind of makes sense. Gradient is the slope of the line, and you can kind of see that if it's going up at the same slope, then clearly it's going to have the same gradient. So let's have a look at an example. What is the gradient that's parallel to the graph of these equations? So in this one, we can see here that the gradient here, we'll call this M1, is 4. So M1 is referring to the fact that it is the gradient of the first line that is parallel. In this, M1 is equal to M2, therefore M2 must be also equal to 4. So basically, it doesn't matter what, we don't know how far away it is from that parallel line. All we know is that both of those gradients will be 4. True or false, are these two lines parallel? So if we're looking to determine if two lines are parallel, we're looking at their gradient. So we've got M1, and what we're trying to show here is that M1 is equal to M2. So in this case, M1 is equal to 2. M2 is also equal to 2. Therefore, M1 is equal to M2. Therefore, they are parallel. Easy. Last example here, a line is parallel to the graph of the rule 5x minus 2 and its y-intercept is 4. The rule of the line for the line is of the form y equals mx plus c. So this is kind of stepping out the problem. State M, so if we know they're parallel, we know that the gradient is the same as the other line. Therefore, for A, M must equal to 5. The value of C, well, in past lessons we've talked about what M is, what C is, and we know that C is the y-intercept, and we're being given that here. So I'm just going to write that down. C equals to 5. Oh, 4, 5. Good lesson here is that sometimes we do make mistakes. It's important that we recognize those mistakes and learn from them. Last part is to find the rules. So we're basically putting M and C into y equals mx plus c. So it's y equals mx plus c. So the line that is parallel to y equals 5x minus 2 that has a y-intercept of 4 is y equals 5x plus 4. So what are perpendicular lines? So perpendicular lines are lines that make an angle of 90 degrees when they cross. Perpendicular lines are on a Cartesian plane are the negative reciprocal of each other. And what we mean by that is that the second gradient is going to be negative 1 over the first gradient. A negative reciprocal, if I have a gradient of 2 over 3, then its negative reciprocal will be negative 3 over 2. If we have a gradient of negative 2, then its negative reciprocal will be positive a half, because we have a fraction with a whole which is negative 2 over 1. We flip it and we make it the opposite operation. If you want to simplify it without using the technical words, what we're doing here is we're flipping the fraction and then we're changing it from positive to negative or negative to positive. So let's have a look at example 2. Use m2 equals negative 1 over m1 to find the gradient of the line that is perpendicular to the graph shown. So in here we have what we call m1. So m1 must be equal to 3. I'm going to substitute this into my rule. So m2 must be equal to negative 1 over 3. And we're done. So the rule is kind of cool how we can put it in with a whole number. This might not always be the case. So let's just make a note. Imagine if we have m1 equals to negative 1/3. If I have that, then I'm going to have m2 equals negative 1 over negative 1 over 3. Becomes a little bit more complicated. If we're good with fractions and negative numbers, then this will be no problem. Historically though, most people aren't great at those two things, so you may need to take the approach that I mentioned earlier. The second part of the problem is answer true and false. The lines y equals 3x and y equals negative 3x plus 2 are perpendicular. So we want to prove that. So we're going to substitute, we're going to say this is m1. We're going to say this is m2. So we're going to say negative 3 equals 1 over 3, which is a false statement because negative 3 is not equal to 1/3. How do we decide if lines are parallel or perpendicular? Well, as mentioned, parallel lines have the same gradient and perpendicular lines have the negative reciprocal of each other. So if the gradients are the same, then the two lines are parallel, and if the gradients are multiplied together to equal negative 1, then they are parallel. So the where this comes from is if we say m2 is equal to negative 1 over m1, if I just manipulate this equation just slightly by timesing both sides by m1, sorry. So we cancel that. What we get is gradient 1 times gradient 2 equals negative 1. And this is where that concept comes from. So let's have a look at some examples determining if they're parallel, perpendicular, or neither. So the first one, A. What I'm going to do is I'm going to multiply the gradients together. So I've got m1 and m2. So m1 is negative 3, m1 is 1/3, as we can see here and here. I'm going to multiply them together, which is negative 3 over 3, which is equal to negative 1. Therefore, they are perpendicular. Part B, y equals a half x plus 2, 2y plus x equals 5. So I know what m1 is, so that is 1/2. However, the second equation isn't in y equals mx plus c form. So what I need to do is make it into y equals mx plus c form. So let's put that up. 2y minus x equals 5. We're going to add x over here. I'm going to put the x first, so x plus 5. I'm then going to divide by 2 each time to get rid of the 2. And what we end up with is a half x plus 5 over 2. If we look at this, we can see that m2 is equal to a half, m1 is equal to a half, so they have the same gradient, which means they are parallel. Therefore, parallel. Beautiful. Last problem. In this case, they're both not arranged the right way, so we're going to have to do something about that. So we're going to do the first one, 3x plus 2y equals -5. I'm going to minus 3x to both sides. So this stuff by year 10 should be pretty standard for you. If you are at a point where you're still finding it hard to solve equations at this point, I recommend seeing someone with and having some kind of intervention with to help fix that problem, because as we go through mathematics in school, it becomes more and more complicated. I guess I'd liken it to being able to trying to run before you can even stand. So for the second one, we have x minus y equals 2. I'm probably going to run out of space. I'm just going to put it up here to make it easier. I'm going to add y to both sides. I'm also going to minus 2 to both sides. So I'm kind of doing a double thing here to cancel out on each side. And what we should get is on the y equals x minus 2, so m2 must be 1. We can see that m2 is not equal to m1, so they can't be parallel. And it's pretty obvious that if I multiply them together, they're not going to equal -1 as well. So they are neither in this case. So if we think back to when we looked at finding the equation, the two things we needed to find were the gradient and the y-intercept. In the past, we used the gradient rule to be able to find that, but because we have certain characteristics of these two lines, which is parallel and perpendicular, we use the knowledge that we have around that to help us find the gradient. The y-intercept actually is found the same way. So your strategy will be identifying the gradient using the information on whether they are parallel or perpendicular, and then using the point on the parallel or perpendicular line to find the y-intercept, which is obviously our c value. And our last step, that's not mentioned here, which is implied, is to put m and c into y equals mx plus c to state the equation. We have some equations here. Find the equation of the line that is parallel to y equals -2x minus 7 and passes through 1, 9. So we have m1 equal to -2, which means m2 is equal to -2 because they are parallel. So I have y equals -2x plus c. At least I know that part of the equation. I need to find a value for x and y, which we have right here. I'm going to put that into the rule that I've made so far. So I'm going to have 9 equals -2 times 1 plus c. So then we have 9 equals -2 plus c. Add 2 to both sides, and c must be 11. Remember, with any equation, we have to state the final equation. We can't just get to that point and say, yeah, that's good enough. We should always state our equation because that's what the question is asking us. So part of that is actually interpreting the equation. interpreting the question correctly. For the second problem, we have perpendicular to y equals 3 over 4x minus 1. It is the negative reciprocal, so m2 will be flipped, and then because it's positive, it'll become negative. So therefore, the gradient will be negative 4 over 3. This second part is the same, so we're going to put this into our equation here. So we're going to have y is negative 2 equals negative 4 over 3 times 3 plus c. We should see that the 3's cancel out here to give negative 2 equals negative 4 plus c. Add 4 to both sides, and c equals 2. The more I think and look at these kind of problems, the more I see how important those basic adding, subtracting, multiplying, and dividing skills are. Lastly, we state our equation, negative 4/3 x plus 2. So I've just put my m and c value in there. For those watching on, here's my m value, here's my c value, and then I've chucked it here and here. Bob's your uncle. So hopefully this has been good for you. If you have any questions, please ask in the comments below. If you like it, like it. If you don't like it, dislike it, and then let me know what I can do to improve what I'm doing at the moment. And thanks for watching.